All right, let's talk about something truly amazing. It's all around us every single day. I'm talking about steel. You might not think about it much, but this material is a superstar. It's the backbone of our cities, holding up the tallest skyscrapers. It's the frame of the car that gets you to work. It's even in the tiny springs inside your pen and the fork you use for dinner. Steel is a special kind of metal. It's mostly iron, but with a little bit of carbon mixed in. This small addition of carbon is what gives steel its incredible potential for strength and versatility. It's a true workhorse material. Think about your own workshop or garage for a second. What do you see? I see hammers, wrenches, screwdrivers, and drill bits. All of them are made from steel. Why? Because steel can be made incredibly hard and tough. It can hold a sharp edge, resist bending, and withstand a lot of abuse. Without steel, our modern world would look very different. We wouldn't have reliable tools, sturdy buildings, or safe vehicles. It's the foundation upon which we've built so much of our technology and infrastructure. It's a simple alloy, but its impact is enormous. It's the reason we can build big, build strong, and build to last. So, what makes steel so special? It's not just about mixing iron and carbon together. The real magic happens when we start playing with its internal structure. You can think of the atoms inside the steel like tiny building blocks. In its normal state, these blocks are arranged in a certain way. But steel has a hidden talent. We can change that arrangement. We can rearrange those atoms to give the steel entirely new properties. We can make it harder, or we can make it more flexible. This ability to transform is what makes steel one of the most useful materials ever discovered by humans. This is where my favorite part comes in, the making. We don't just get steel and use it as is, we get to modify it. We get to be alchemists in our own right. The process of changing steel's properties is what this is all about. It's a craft that has been perfected over centuries, from ancient blacksmiths forging swords to modern engineers designing parts for spacecraft. It's the secret sauce that turns a simple piece of metal into a high-performance component. It's a fundamental process that unlocks the full, incredible potential hidden within every single piece of steel. It's just plain cool. So how do we perform this amazing metal magic? The answer is simple and powerful. We use heat. The process is called heat treatment. In the simplest terms, heat treatment is like cooking for metal. Just like you put a cake in the oven to turn a gooey batter into a delicious solid treat, we put steel into a furnace to change its internal properties. We are carefully controlling temperature to tell the atoms inside the steel how to behave. It's not about melting the steel down and reshaping it. It's about changing the steel while it's still in its solid form. It's a precise and controlled process. Let's break that down. Heat gives the atoms inside the steel energy. When the steel gets hot enough, those little atomic building blocks I mentioned earlier get excited. They start to move around and unlock from their regular positions. This allows them to rearrange into new, different patterns. Think of it like a crowd of people standing in neat rows. If you give them a reason to get excited, they'll break formation and start mingling. With steel, heat is that reason. This is the moment of change, the point where we can start to influence what the steel will become. The key here is control. This isn't just about chucking a piece of steel into a fire. Oh no, that would be chaotic and unpredictable. Heat treatment is a science. It involves very specific temperatures for very specific amounts of time. Different temperatures and timings will result in different atomic structures. This, in turn, results in different physical properties. One recipe might make the steel incredibly hard, perfect for a cutting tool. Another recipe might make it tough and springy, ideal for a car's suspension spring. It's all about following the right recipe for the job. So, heat treatment is our way of giving instructions to the steel. We are telling it what we need it to be. Do we need it to be hard enough to cut other metals? Or do we need it to be tough enough to absorb the shock of a hammer blow without shattering? We can achieve both, but not usually at the same time. There's often a trade-off. Making steel harder can sometimes make it more brittle. The art and science of heat treatment is finding the perfect balance of properties for a specific application. It's a fascinating puzzle with fire and metal. The entire process of heat treatment can be broken down into a three-step dance. It's a rhythm of temperature changes that every piece of heat-treated steel goes through. The first step, as you might guess, is heating. We place the steel part into a furnace or a forge and slowly bring its temperature up. We have to do this carefully. We are aiming for a very specific target temperature, known as the critical temperature. This is the point where the internal atomic structure, called austenite, begins to form. It's the magic number where the steel becomes ready for transformation. Once we reach that perfect temperature, we move to the second step, holding. This is also called soaking. We don't just hit the temperature and immediately cool it down. We need to hold the steel at that high temperature for a specific amount of time. Why? We need to make sure the heat distributes evenly through the entire piece. If you have a thick piece of steel, the outside will get hot before the inside does. The soaking period ensures the entire part, from the surface to the deep core, has reached the target temperature and has fully transformed into that new atomic structure. It's like letting a steak rest to cook through. Now for the most dramatic part of the dance, the third step, cooling. This is often called quenching. This is where we lock in the new properties. How fast we cool the steel is incredibly important. In fact, it's probably the most critical step of all. To make steel very hard, we need to cool it down extremely fast. This is often done by plunging the red-hot steel into a liquid like water, brine, or oil. This rapid cooling, or quench, traps the atoms in their new, highly stressed and very hard structure called martensite. It doesn't give them time to settle back into their old, softer arrangement. But what if we don't want the steel to be super hard and brittle? What if we need it to be tougher? In that case, we cool it down more slowly. We might let it cool in the open air, a process called normalizing. Or for maximum softness, we might leave it in the furnace and let it cool down very, very slowly over many hours, which is called annealing. The speed of the cooling step is the final control knob we turn. It dictates the final balance between hardness, toughness, and ductility. It's the grand finale of the heat treatment dance, determining the steel's final character. So, where do we see the results of this amazing process? I'll tell you, everywhere. Let's go back to the workshop. That hammer you own needs to have a very hard face to strike nails without deforming. But the handle end of the head needs to be softer and tougher, so it doesn't crack from the shock. This is achieved through differential heat treatment. The face is heated and quenched rapidly for hardness, while the rest is cooled more slowly for toughness. The same goes for a good wood chisel. The cutting edge is made incredibly hard to stay sharp, a direct result of a precise heat treat recipe. Now think bigger. Think about the car you drive. The gears inside your car's transmission are a perfect example. They are constantly meshing under huge amounts of stress. They need to have surfaces that are extremely hard to resist wear and tear over millions of rotations. But they also need a core that is tough and resilient, so a tooth doesn't just snap off under a sudden load. This is achieved by a process called case hardening. Only the outer surface, or case, of the gear is heat-treated to be hard, leaving the inner core tough. This gives you the best of both worlds. Even the body of your car relies on heat treatment. Modern cars use advanced high-strength steels to create a strong safety cage around the passengers. These steel parts are heat-treated to be incredibly strong yet lightweight. This allows car manufacturers to build vehicles that are both safer in a crash and more fuel-efficient. The giant steel beams that form the skeletons of bridges and skyscrapers are also heat-treated. They are normalized to refine their internal grain structure, making them strong and uniform, ensuring they can bear immense loads safely for decades. Ultimately, heat treatment is one of the most important manufacturing processes we have. It's a force multiplier. It takes a good material, steel, and makes it great. It allows us to tailor the properties of a metal component to perfectly suit its job. Without it, our tools would be dull, our machines would wear out quickly, and our structures would be weaker and heavier. It's a testament to human ingenuity, using the fundamental forces of nature, like heat, to transform the world around us. It's science, it's engineering, and to me, it's pure building magic.